So I made Vimium for the Linux desktop so you can navigate GUIs without using your mouse. If you're not familiar with Vimium, Vimium is a browser extension that lets you navigate your browser using Vim-like key bindings. For example, you can use T to open up a new tab or HJKNL to scroll through websites, but I think Vimium's best feature is using the F key, which shows you hints on the website of elements that you can click on. But even as cool as that is, I think there's one really big problem, which is that it only works in a browser, and even then, it doesn't even work on all parts of a browser. So that's what I implemented over on the Linux desktop with an application called Hints. With Hints, you can bind a keyboard shortcut to show you hints for a current application, and then you can interact with different elements of the GUI using your keyboard with things like right-clicking, left-clicking, hovering, and even dragging GUI elements around. The application is built with Python, it's free and open source, so I'll leave you a link in the description below to the GitHub repo where you can go ahead and try it if you want to. Now, this is an application that I've actually been wanting for myself for a really long time, and even browsing on Reddit, I can see that there's been other people who have been interested in the same thing, but for some reason, it just doesn't exist on Linux. Now, over on Mac OS and on Windows, you do have applications that actually do this. So for Mac, you have Home Bro and Shortcut, and then on Windows, you have Hunt and Peck and Fluent Search. But on Linux, that's just not the case, and you don't have an application like this. And the reason behind that is because the way these applications work is that they use the operating system's accessibility layer to essentially see where elements are on the screen for different applications. On Linux, this was a little tougher to actually find a way of doing things to make this work. I spent quite a bit of time trying to figure out how exactly I was going to do this on Linux, and I went through a few different options. The first thing I thought about was using computer vision to essentially take a picture of an application and then figure out where clickable elements within that picture might be, and then using that to get the coordinates of the screen and figuring out where to click on things. However, as you can imagine, this isn't a very good solution because you really have no fine control over what a clickable element actually is. I then started looking at machine learning models and AI to see if I can maybe make a prompt to prompt an AI based on the different UI elements so that we can have more fine-grained control and know what element is actually clickable instead of just giving you hints for anything and everything. The problems I ran into there was finding models that were complete enough to actually know what UI elements were clickable, and also it was just painfully slow. It would just honestly be a lot quicker to grab a mouse and click on an element at that point, really because of the compute time, especially when dealing with AI models that were running locally. It just wasn't a really good experience. And finally, what I ended up settling on, which is the primary way that Hints works to gather UI elements, is using Atspi. Now, Atspi is built by the GNOME Foundation, and it stands for the Assistive Technology Service Provider Interface. Essentially, it's just the closest thing we have on Linux to a good accessibility solution that works across many GUI frameworks. Now, something to know about Atspi is that I actually found it very difficult to find any code examples online or just really anyone talking about it online. And I think that gives you a sense of the state of accessibility on Linux. It's just not very good. Now, furthermore, as I mentioned earlier, Hint is written in Python and Atspi is written in C with introspection to Python, which made things a little difficult to work with at first because, again, there are really not many code examples online. The good thing is I do know C, so if I needed to look something up, I would just go over to the source code and find out how that works to then be able to do it in Python. I will also mention that I learned a lot from Accessizer. Accessizer is a program also written by the GNOME Foundation, which uses a Python wrapper called PyAtspi to interact with Atspi. It's not quite the same thing, and Hints doesn't use it just because it's now deprecated, but it was a really good, useful learning tool to know how to interact with Atspi. Now, with all of that out of the way, let me actually show you how Atspi works. So, like I mentioned before, Hints is really just an open source program, so you can go ahead and see the source code for yourself. And here we are. So this is Hint at the entry point. And so the best place to start is honestly just Hint itself at the entry point with a main program, like as you would imagine, the main function for any program. And what you'll notice is that Hint is really just a CLI application, and you call Hint by binding your own keyboard shortcuts. So if I were to show you that, I can open up, for example, Brave real quick, and I have it bound to Super I. So Super I gives me hints for everything, and then you can interact with it. Like I do AD up there to open up a new tab. I can close this tab by doing AD again, and so on. You know, it's just like Vimium works as you would imagine if you've used it. And so for Hints itself, The magic happens that we want to really go over is to show you how hints are created. And like I mentioned before, I'm using Atspi, but I'm also using a backup, which is OpenCV for computer vision, in any case where you can't find something. So if I try hints here in my terminal application, again, Super I, you'll notice that we have hints pretty much with everything. And that's because that's the backup whenever Atspi can be used. So the thing is that Atspi only works for accessible applications that implement it within their GUI toolkits. And as you can imagine, a terminal doesn't really have that because it's all text-based, which is why we're using the backup here. And you just stop that by using escape. And so now the magic really happens is with these backends. And what I mentioned before, what I really want to go over, is the Atspi backend. So if I go down a little bit here, you'll see we have this get children function for backends. And that's how you get the interactable elements from a child. And so for Atspi specifically, if we go over to the code base for that backend, right here, and then go down below, we have this function, which is the get children function. And down below, this is just a bunch of states that Atspi takes in to know what elements you want to go ahead and gather. These are all, by the way, customizable, so you can customize them to see what kind of elements you want to get. It's a little different between different applications, but for the most part, the defaults work really well. And so now what we want to really see is this get children of interest, which is when we call Atspi to get elements for an application. And so this really comes down to this. This is kind of the magic that just kind of works, which is great. So for most applications on Atspi, I'm using the collection interface. And the collection interface is a really nice way to query for specific elements, but also really, really fast because it kind of knows where all the elements already are. There is one drawback to some applications, which I'll get to in a bit, but for the most part, that works. And then we just do some filtering down here for basically to make sure that the elements are actually visible because Atspi does give you back a bunch of elements that might not always be visible because they might be off screen or they might be part of specific context menus. And so going down here, kind of the drawback that I want to point out, and really quickly, just to show you this, what ends up happening is once we have a child, we just put it part of this child class, which very simply is just a class that has information about the positioning and the size of these elements, which could have probably been a data class, so it might be better, but pretty much the same thing. And then down here, this is kind of a drawback I want to point out. So Atspi is really good at getting things really quickly if you use the collections API. The bad thing is that the collection API have to actually be implemented by the GUI framework that uses Atspi. If it's not implemented, the collection interface, then you can't use the collection interface to query for elements. So it gets very, very slow. And the only way of doing things is really to do things recursively. So that's why I have this recursive function here. If you look at the recursive function, if I scroll down to the bottom, essentially what we're doing is for every single element on the screen, starting at the very top point, basically at the root node, you go down through every single element and do so recursively by calling the function over again for every single element in the tree. And I think a really nice way of seeing this is if I open Brave up again and then use Exerciser. That's the application that I mentioned before that I learned a lot from. Exerciser lets you see basically the GUI implementation of a tree for the entire application. So what I mean by that is we have Brave open. If I go here and look at this new tab, you can see this as I'm clicking on things, Exerciser is highlighting elements. And so for example, as you go down this tree and even further, we go down a few, here's the tab at the bottom. So what I'm doing is for every single one of these little blocks that I'm doing in the tree, I'm iterating for every single one of the inner blocks like this. And so if I look at this one, this has its own inner blocks, as you can see, and look at this one, this has its own inner blocks. So the reason I'm pointing this out is because for some applications, this can be very slow and it becomes a huge problem computationally wise, especially as you add more elements on the screen. So if I were, for example, to click on a new tab, that's now a whole new element that I have to iterate over. And I open up a new tab, now we have a whole bunch of the same elements. And so I have to do that every single time for every single one of the elements recursively, and that can get really slow. And so yeah, that kind of sucks in a way because it makes it so hints is really slow in some applications, but really fast for other applications that do support that collections API. But what are you gonna do? I guess it's better to have hints and not have any hints at all. That's just kind of a drawback of Atspi itself. And not really so much Atspi, but more the frameworks that don't support that collection API from Atspi. If a lot more frameworks did, then it would be a lot quicker. For example, I know while testing this, I looked at an application called Neko, which is, or I believe it might be pronounced Heko, whatever it's pronounced, that essentially is a client for Matrix, and that does not support the collections API. And as that grows and more elements and more basically messages are shown up, imagine an application like Discord where you have more and more messages showing up, that gets really, really slow. I've seen load times of up to like 10 seconds just to show you hints, because again, we have to do that recursively, and there's just really no way around that. I've tried implementing like multi-processing, and that still wasn't great. That's just the way it works for now. But hopefully, again, I think that's more, it shows you the accessibility state on Linux. It's just not really good overall, but for most applications, it works pretty well. So yeah, overall, that's Atspi, and that's hints overall. That's mostly what I want to talk to you about. There's also a bunch of stuff that I could go into. I know once I built this application and I first shared it on Reddit, there was a lot of support, people asking for Wayland support, which we do now support. It now supports Wayland. Now, Wayland is a little bit different because on Wayland, unlike X11, Wayland doesn't really give you the ability to kind of snoop on different programs to know where specifically windows lie. So Atspi still works on Wayland, which means I can still get the elements of applications. The bad thing is that I can't specifically know where a window lies universally for all of Wayland. And so the way I've been able to implement that is to essentially create a different implementation on a per Wayland compositor basis. So as you can see over here on this, we have Sway implementation, and there's also now support for Hyperland, which I don't think it's here. But it is supported now. So if I go over to Sway, this might be an older branch that I have. It's just not up to date. So here, as you can see, it's really simple to implement because it's really just a matter of having a few functions, and it makes more sense to go down here. So really all you need to implement a new Wayland compositor is to get the name of the currently focused application, get the window PID of that to differentiate it from different windows. We also have the Windows extent, which is basically the position and the size of a window to know how to properly put hints on different elements. And then just the name of the Windows system, that's just to differentiate between different Windows systems. But that works really well. And so now we have support for that. And I'm currently working on support for KDE, which is working as of now. The one thing that I will mention that kind of is hard with Wayland is mouse support. So right now we're using wide U tool to essentially be able to control the mouse in different actions. But it seems that wide U tool, although it's supposed to work independent of any Windows system, it's a kind of hit or miss based on the way the different Wayland compositors work. So that's been a bit of a challenge. And then something else that I've noticed is that I've had some complaints, people mentioning that it might be a little bit difficult to install. And hopefully in the future, I can go ahead and make it easier to install. But kind of the reason why that is because on Linux, we have no universal way of doing things. Everyone has their own window managers and compositors and, desktop environments. And there's no, again, it comes back down to the fact that their accessibility support is not very good overall in Linux. So there's different ways of doing different things. And that has been a challenge because it's different on a per environment basis. We do have some documentation on the Hint GitHub repo in the wiki that lets you have an idea of how to do things for specific desktop environments and window managers. But again, there's just no way I'm going to be able to get every single desktop environment and window manager out there. But for most, it's there and it's been really good. But yeah, I think those are just future improvements that I have to work on in the future. But yeah, I'm really happy because now I have something that I'm able to use exactly the way I wanted to use it. And I've been using it for like the past few months now. And it's super awesome. It makes me a lot more productive and it's just going to get better over time. So yeah, if you want to go ahead and try it, go ahead and give it a try. I'll leave the GitHub link down below.